Okay, good afternoon, all of you. Welcome to this lecture of refrigeration air conditioning. So, in last lecture, we have taken the MCQ test for VRS system, vapor absorption refrigeration system. And like I said in last lecture, today we are going to start the second section. So, in first section, I will just take a quick review what we have learned in the first section. First section was all about the basic components of a refrigeration system. So first chapter was related to VCRS system, vapor compression refrigeration system. Major components we have studied there. There was a evaporator, condenser, compressor, and throttling valve. Apart from major components, there were some auxiliaries. So in second chapter was related to multi evaporator and multi pressure system, in which we studied why it was needed. We should go for multi-stage compression, where we need a multi evaporator system, right? Then third chapter was related to refrigerant, in which we studied not only we studied the refrigerant, but also we studied the ozone depletion and global warming. So whoever are refrigerant who are contributing to the ozone depletion and global warming, they are being now phased out. And coming to the fourth chapter, VRS system we have studied in very detail. I explained you what are the advantages of using VRS over VCRS. Then we have seen some system like lithium bromide system and electrolux system. So in last lecture, we have taken the MCQ test. I also provided the practice test for you. It is valid till end of this month. Okay. One thing I remembered from end of this month that 30 September is last day for registration to get 2021. So please register. So those who are preparing for GATE, they will assume that they have already filled it. Those who are not preparing for GATE, please take it in positive manner. That GATE preparation will sharpen your technical knowledge. So it is your wish in the end if you want to apply or not. But GATE preparation will give you that confidence that you can crack any technical aptitude if you will apply in your future. Okay. So register for the gate and make sure you have selected our college, engineering college, because in that drop down menu there are two colleges, pharmacy college and engineering college. So make sure you have selected our college only, right? Okay. So we are entering into the second section and the first chapter of the second section or fifth chapter of our syllabus, it is psychrometric. Okay. So when I say the psychrometric is the science or the subject which studies the properties of a moist air. Okay. So from your school or from your high school, you have studied the properties of air. You have studied the ideal gas law equation, P is equal to nRT. So in that it was assumed that the gas is ideal. Okay. Then you have studied the air in IC engine, because air was a major contributing factor in calculating the performance of a diesel engine or a petrol engine, whatever it may be. Okay. So when I say air, okay, so I ask you this question that when I say air, so what are the major components you can imagine or you can think of? Yes, so I'm waiting for answers. So the question is that when I say air, what are the major contributing factors of air? So if I take 1 kg of air, what will it will contain? So that you have to answer. So I'm waiting for answers. Oxygen, okay. Rohit Singh, oxygen, nitrogen. So others, you can unmute yourself. You can tell, no problem. Arbaz is saying carbon. Arbaz has kept DP of Mahendra Singh Dhoni. So I think he's a Dhoni fan. Good. Arbaz. Right. Okay. Again, moisture, uh, oxygen. Yes. Uh, okay. So others. So question is, when I say air, what are the major contributing factors? So that you have to reply. Noble gases. Okay. Noble gases means he means helium and other those argon, right? Xenon, radon. Those gases will be there. Okay. So whatever you are talking about only gas. Okay, here Rohit has given one different answer, moisture here. Yes, so moisture means that will be liquid. Okay, so you are given example for gas, you are given example for liquid also. So as Rohit has said, moisture, and again Rohit has given it polluted or not. So there will be solid particles also, right? So there will be dust particles suspended in air. If you take pollution, so that there will be soot particles which are coming out of your exhaust system. So those who are residing Pandharpur, like Arbaz, so they are very familiar with the environment of Pandharpur. So a lot of dust is there in Pandharpur. So when I say air, air will contain, yes, of course, it will contain oxygen, nitrogen, and argon, other gases. Carbon dioxide it will contain as gases. In liquid, it will contain water particles, so that will be moisture. Third, if I talk about solid, in solid also it will contain dust particles, pollution, soot particles. Okay, so all those will be counted. Then there are particulate matter like PM 2.5, PM 10. So those will come under solid category. Okay. So air, if you see, it is a mixture of solid plus liquid plus gaseous substances. And if you take level from ground, if you take like 1 kilometer from ground, so in that region, air and moisture are major contributing factors. If you take about 10 kilometer, you won't find any pollutant particles because pollutant particles they have some density and they won't go in upper region. So in that case, that pollutant particles or solid particles will be vomited out. Again, if you take above that, there will be no moisture particles. So if you go like up to troposphere, top position of troposphere or stratosphere, in that case, you will observe only dry air. Okay. So this is how the composition goes. So because the density, if you see the atmospheric this levels, troposphere and stratosphere, as the level increases, density of that level decreases. So with decreasing density, what happens? Moisture is removed, then pollutants are removed, and then we get a dry air at the stratosphere. So this is kind of off topic, but I think you should know this. Okay. So we'll see what is a psychrometry. Before that, these are the contents of the syllabus. So moist air, then psychrometric properties that we'll see, processes, ADP, apparatus dew point, coin condition line, sensibility factor, bypass factor. So this will be related to your numerical part. Air washer and its applications. Air washers means the one air conditioning system that you can use throughout the year. You can use it in summer, you can use it in winter, you can use it in rainy season. So that will come under air washer and its applications. So the objective or the expected outcomes from this chapter are you should know what are the properties of moist air. Okay, I'm not saying air. I'm saying moist air. So you should know the properties of moist air. Then how to calculate these properties. Then how to interpret these properties, and then you can say there is a cooling, there is heating, there is a humidification, there is a dehumidification. So all those processes we'll see in this chapter. Okay, so this is just an introductory part before you go to actual calculations of air conditioning system. So before that, you should know what is a dew point temperature. You should know what is Wilbur temperature, what is the humidity, what is relative humidity. Okay. Then what should be the air pollution or accepted air quality, indoor air quality, and what are the processes. So if you take air conditioning in our home, so air conditioning not only it does the वर्क ऑफ कुलिंग फक्त एअर कंडिशन म्हणजे कुलिंग करत नसतं. जर तुम्ही थोडा वेळ एसी रूम मध्ये बसता तर थोड्या वेळ तुम्हाला जाणवेल की तुमची स्किन ड्राय पडते. काही काही जणांचा तर डोळ्याचा प्रॉब्लेम असतो, डोळ्यातलं मॉइश्चर कमी झाल्यामुळे तुमचे डोळे ड्राय पडतात. So air conditioning is all about cooling and dehumidification. Okay, so what are these processes actually? So that we'll see in this chapter, so that you will get familiar. Once you get familiar to these basic terms and processes, then we can move to the design part in the next chapter. Okay. So the psychrometry will begin. Okay. So the name psychrometry is given to the study of properties of air water vapor mixture. So let me just start that laser pointer. Okay. So the name psychrometry is given to the study of properties of air water vapor mixtures. Okay. So we are studying the moist air. If I say air water mixture, that will be a moist air. Atmospheric air is a mixture of many gases plus water vapor and a number of pollutants. So you can see a diagram at the right side. So if I take what you can say this is a, like a pie chart, not pie chart. This is a like subset. So the bigger domain here, it is atmospheric air. Then we have smaller domains here. So first domain you can see here, it is a mixture of permanent gases. So this will be there in the air: nitrogen, oxygen, argon, hydrogen. Then we have water vapors, which are due to the evaporation of water from the lakes and oceans. Okay, so that will be water vapor. Then we have dust particles, fumes coming out of the chimneys of the industry. Then we have dust particles. So like we have gases, we have liquid, and we have a solid. So atmospheric air, this big domain will contain these gases. Then it will have water vapor, and then it will have dust particles. But when I say moist air will not contain the dust particles. So when I install a air conditioning system, the utmost care it is being taken that we provide a filter. So like if there are any DSC students here, they know about the HEPA filters, HEFA. So HEPA filters are very popular, which are used to remove these dust particles, because we want to supply fresh air to the living room, right? So in that case, we have to first remove the solid particles. Then we can modify the temperature and humidity ranges. The concentration of water vapor and the pollutants decrease with altitude. So this point I already explained to you. This concentration of water vapor and pollutants decrease with altitude, because as the altitude increases, density decreases. And above an altitude of 10 kilometer from our sea level, atmospheric air consists of only dry air. So at the troposphere, okay, so troposphere extend up to 20 to 25 kilometers. So in that troposphere, we have largely containing gases, water vapor, and dust particles. If you take a level of 10 kilometer above the ground, in that case, you will observe only dry air. Okay. So you can write shortly that what is the psychrometry. You can write the definition that the name psychrometry is given to the study of properties of air, water, vapor, mixture. And you can also draw this diagram. So this diagram will give you a slight idea about the atmospheric air. Okay, so I hope you have drawn this. Actually, two students came to meet me. Uh, they're applying for the MS, and for MS, they need some LOR, letter of recommendation, and transcript. For that purpose, they came in the college. Okay, so those who are applying for MS or thinking of doing MS, good news that flight has been started. So students are now going to the Germany and the European countries. Those flights are started, and those who are interested, they can contact me or we can discuss later. Okay. Right. So we have studied or we have just seen the psychrometry. So it is a science or it is a subject which deals with the properties of the moist air. Air contains the gases as well as water vapor and as well as dust particles. Okay. So what is a moist air? So the moist air here, it can be thought as a mixture of dry air and moisture. So we are not discussing about the dust particles. We are not discussing about the soot particles. We are discussing about only dry air, that is a gas, and here moisture, that means a water vapors. So moist air can be thought as a mixture of dry air and moisture. So in 1949, a standard composition of dry air was fixed by the International Joint Committee on Psychrometric Data. Okay, so this joint committee on psychrometric data, they have decided that what should be the composition. Not decided, they have calculated and they have fixed that one and average. What is the contribution of all the gases in the moist air? Okay, so there is a table in front of you. So if you take air in case of dry air, so dry air means that will not contain the moisture. So in dry air, what are the constituents? So there is a table. First table is constituent, second is its molecular weight, and third is mole fraction. Okay, so first oxygen, so we know its molecular weight is 32. Its mole fraction, if you take 1 mole of dry air, so in that 1 mole of air, dry air, what will the mole fraction of oxygen? That will be 0.2095, or generally we tell it as a 21%. On an average, we tell it as a 21%. Second is nitrogen. So nitrogen's molecular weight, it is 28, and the mole fraction here it is 0.7809. That means near about 78%. 78-21, remaining 1%, it will be consisting of other gases like helium, like argon, xenon, radon, carbon dioxide, sulfur dioxide. All those gases will contribute only 1%. Second, we have argon here. So its molecular weight here it is 39.9. Its mole fraction is 0.0093. Then we have carbon dioxide here, which is a major contributing factor in global warming. It's the molecular weight here it is 44. Mole fraction in the air it is 0.0003. Okay. So based on above composition, the molecular weight of dry air is found out to be 28.966, and the gas constant R for dry air it is 287.035 joule per kg Kelvin. So we are using these values from last semesters. That molecular weight of dry air we are taking it as a 28, and that R value for air that we generally take it as a 287 joule per kg Kelvin. Okay, so this is about dry air only. If I talk about moist air will contain dry air plus water vapors. Okay. Then coming to the saturated air. So nowadays this weather, if you see, it is raining outside, and sometimes the weather, it is like if I reduce the temperature, anytime that water particles will start to condensate. So if you have seen, if you buy a Coca-Cola or Pepsi bottle, which was previously was inside the fridge and you have taken out, in that case you will see the water particles are starting to form on the surface of the Coca-Cola bottle. So what is happening in that case? Actually, this water particles are getting condensed on the cool surface of the Coke or Pepsi bottle. Okay, so it is depending on the temperature. On this condition, if I reduce the temperature of atmospheric air, one point will come in which these water particles will be saturated. That means it will, if I reduce the temperatures just a little bit after that point, after that temperature, water particles will start to condensate. But before condensation, whatever condition it is there, so that condition we are referring it as a saturated condition. Okay, that means this water particles and air, they both are exerting equal pressure on each other. So that is a condition of saturation. So at a given temperature and pressure, the dry air can only hold a certain maximum amount of moisture. When the moisture content is maximum, then the air is known as the saturated air. So this again depends on the pressure and temperature conditions. ठीक आहे, जसं की आता जी एअर आहे त्या एअर मध्ये जास्त मॉइश्चर अजून आपण ऍड करू शकत नाही की बिकॉज ऑलरेडी इट कंटेन्स that moisture content is very high in rainy season, so we cannot add more moisture to it. Okay, so that is the concept of humidity. We'll see that later. But if you take the weather of winter, ज्यावेळेस हिवाळा असतं, हिवाळ्यात आपल्याला माहिती आहे एअर कशी असते, ड्राय असते. दॅट मीन्स दॅट एअर इज हॅव्हिंग व्हेरी लेस वॉटर कंटेंट, and in that air we can add as much water vapors as we want. But opposite case is in the रेनी सीझन. रेनी सीझन मध्ये काय असतं, एअर मध्ये ऑलरेडी वॉटर पार्टिकल्स किंवा वॉटरचं कंटेंट जास्त असतं, त्यामुळे आपण त्यात वॉटर कंटेंट अजून ऍड करू शकत नाही. बट ऑपोजिट केस इज इन विंटर. विंटर मध्ये ड्राय एअर असते, दॅट मीन्स इट हॅज व्हेरी लेस पर्सेंटेज ऑफ वॉटर वेपर्स. सो इन दॅट केस यू कॅन ऍड वॉटर वेपर्स टू इट. ओके, सो सॅच्युरेटेड इज द कंडिशन वेन एअर ज्यावेळेस एअरला वाटतं की आता ह्याच्यापेक्षा जास्त मी वॉटर पार्टिकल्स होल्ड करू शकत नाही, ज्यावेळेस वॉटर पार्टिकल एक्सिड होतील त्यावेळेस काय होणार, ते दे विल स्टार्ट टू कंडेन्सेट. ओके, सो इफ यू सी मॉर्निंग इन विंटर, जर तुम्ही हिवाळ्यातल्या एखादी मॉर्निंगला बघितलं त्यावेळेस दव फॉर्मेशन झालेलं असतं, तर पानावर दव निर्माण होतं. ठीक आहे, तर कशामुळे असतं की एअर आता त्यापेक्षा जास्त वॉटर कंटेंट होल्ड करू शकत नाही, त्यावेळेस काय होतं, ते वॉटर पार्टिकल्स आपोआप त्या सरफेसवर जमा व्हावं लागतं. सो दॅट व्हॉट वी कॉल इट ॲज अ ड्यू फॉर्मेशन. Don't worry, we'll see this dew formation, all these terms later. So when a moisture content is maximum in the dry air, then the air is known as saturated air, which is established by a neutral equilibrium between the moist air and the liquid or solid phases of water. For calculation purposes, the molecular weight of water vapor is taken as 18.15.015 and its gas constant is 461.52 joule per kg Kelvin. Okay. So this is about the water. So in previous slide, we have seen that molecular weight of dry air, we take it as a 28, and that our gas constant, it is 287. So in this slide, we have seen that the molecular weight of water, we already know for H2O, it is 18, and its gas constant, it is 461.52 joule per kg Kelvin. Okay. So generally the air we consider here, it is a moist air, it is a mixture of dry air and water particles. But when a situation comes that dry air cannot hold the water particles anymore, or in other words, I will say that water particle will start to condensate on the surfaces, that condition we are taking it as a saturate. त्यापेक्षा जास्त आता तो water content ते handle करू शकत नाही, जास्त झाले की काय होणार, ते condensate होणार. So that is about the saturated air. Then coming to the main point here, which is a governing factor in psychrometry, that is nothing but the Dalton's law of partial pressure. So this you might have already studied in first year, Dalton's law of partial pressure. Okay. So the actual statement of Dalton's law of partial pressure, it is that the total pressure in a mixture. So there is a mixture of gases. So you can see here on the screen. So there is a gas A, okay, with a volume VT and pressure of PA. Then there is a gas B, pressure of PB. When I mix together, so this container will contain gas A as well as gas B. Okay. So if I take total pressure acting in this system as P, so here it is taken as P. So this total pressure will be summation of partial pressure of gas A, partial pressure of gas A, that is nothing but PA, plus partial pressure of gas B, that is nothing but PB. Okay. So total pressure P is equal to PA plus PB. So that is nothing but the Dalton's law of partial pressure. So if I take a mixture of two gases, okay, if I want to calculate total pressure in the system, that total pressure will be summation of partial pressures of each gases. So if that a system contains 10 gases, एका सिस्टम मध्ये समजा 10 प्रकारचे गॅस आहेत, त्या सिस्टमचं तुम्हाला प्रेशर काढायचं, ते प्रेशर काय असतं, इट इज अ समेशन ऑफ पार्शियल प्रेशर ऑफ each gas. तर गॅस 1 चं पार्शियल प्रेशर मी घेणार, गॅस 2 चं घेणार, असं करत मी गॅस 10 पर्यंतचं पार्शियल प्रेशर घेणार. I will take the summation whatever summation it will be, that will be total pressure acting in the system. Okay. So this is about the Dalton's law of partial pressure. If I apply the same in our case, so our case is nothing but moist air. Moist air means it contains dry air and water vapor. So we have a mixture of dry air and moist air. In that case, if I take the total pressure, so that will be summation of partial pressure of moist air, sorry, partial pressure of dry air plus partial pressure of water vapors. So that summation will give you total pressure acting in the system, right? So I'll quickly read this. So Dalton's law of partial pressure. So total pressure, both dry air and water vapor in air generally follow the ideal gas law. So the total pressure here, P is equal to PA. So PA is nothing but partial pressure of air plus PW. PW is partial pressure of water vapors as per Dalton's law of partial pressure. So total pressure will be equal to partial pressure of air plus partial pressure of water vapor. Here both P and PW are partial pressures. Okay. So Dalton's law of partial pressure is applicable to all gaseous mixtures. If I apply that law to our case means moist air. In moist air, it contains dry air plus water vapors. So our equation for moist air, it will be total pressure in a moist air mixture will be summation of partial pressure of dry air plus partial pressure of water vapors. Okay. So if you want to write, you can write, or if you want to draw this diagram, you can draw, or you can simply write it as a gas A with partial pressure PA plus gas B partial pressure PB will be equal to P. Okay, so total gas mixture will be equal to PA plus PB. Okay, so I have a question here. What is a partial pressure? Partial pressure, this term, actually this is the simplest term here. पार्शियल प्रेशर मराठीत सांगायचं झालं तर प्रत्येकानं किती प्रेशर अप्लाय केले. जसं की आता मी आणि प्रणील आहेत, आपण दोघं कार ढकलते, काय ते बंद पडलेली कार ढकलतोय, त्यात मी माझ्या वेटनुसार बॉडी फोर्सनुसार ठराविक फोर्स अप्लाय करणार, प्रणील त्याच्या बॉडी फोर्सनुसार त्याच्या कॅपॅसिटीनुसार ठराविक प्रेशर किंवा फोर्स अप्लाय करणार आणि टोटल एक फोर्स त्या गाडीवर अप्लाय होणार. समजा गाडीवर फोर्स जर 100 न्यूटनचा अप्लाय होत असेल, त्यातलं माझं कॉन्ट्रीब्युशन असणार आहे 60 न्यूटनचं, तुझं कॉन्ट्रीब्युशन असणार आहे 40 न्यूटनचं, टोटल कॉन्ट्रीब्युशन झालं 100 न्यूटनचं. So it works in that way. So if I talk in the terms of pressures, if there is a pressure of 100 Newton per meter square, my contribution will be 60 Newton per meter square, your contribution will be 40 Newton per meter square. So 60 Newtons per meter square, that will be my partial pressure, 40 Newton per meter square, that will be your contribution. So in that way, this partial pressure term works. Okay. Partial pressure, you can also assume it as like individual pressure. तर त्या गॅसचं इंडिव्हिज्युअल प्रेशर ते किती अप्लाय करतोय, गॅस ए. गॅस बी त्याचं इंडिव्हिज्युअल प्रेशर तो किती अप्लाय करतोय. टोटल प्रेशर ऑब्विसली काय असणार आहे, गॅस एने किती प्रेशर अप्लाय केलंय प्लस गॅस बी ने किती प्रेशर अप्लाय केलंय. सो दॅट विल बी टोटल प्रेशर ऍक्टिंग इन द सिस्टम. Okay, so I hope you have written that equation. PA plus PB will be equal to P. If you want to draw the diagram, you can draw the diagram also. The next concept in this, it is a vapor pressure. So partial pressure, you have just seen, it is the pressure of individual gas. Vapor pressure is another concept. Vapor pressure comes when there is a saturation. That's air आणि वॉटर पार्टिकल्स एकमेकाच्या इक्विलिब्रियम मध्ये असतात किंवा सॅच्युरेशन मध्ये असतात. त्यावेळेस जे प्रत्येकाचं प्रेशर आहे ते त्याला काय म्हणतात, वेपर प्रेशर. सो दॅट इज अ प्रेशर अप्लाइड बाय वेपर ऑन द लिक्विड. ओके. So there are two pressures which govern all this psychrometry. First is partial pressure, second is vapor pressure. पार्शियल प्रेशर म्हणजे तुम्ही कोणत्याही कंडिशनला एखादं मिक्सर घ्या, त्यावेळेस तुम्ही त्यातल्या इंडिव्हिज्युअल कंपोनंटचं किती प्रेशर आहे ते कॅल्क्युलेट करा, सो दॅट विल बी पार्शियल प्रेशर. बट वेपर प्रेशर इज स्पेशल कंडिशन इन विच यू रिक्वायर इक्विलिब्रियम. त्यावेळेस तुम्हाला सॅच्युरेटेड एअर पाहिजे. सॅच्युरेटेड एअर म्हणजे काय, एअरचे आता मॅक्सिमम मॉइश्चर धरायची कॅपॅसिटी जवळपास संपत आलेली आहे. आता ह्याच्यापेक्षा जास्त एअर मॉइश्चर धरू शकत नाही. जास्त धरलं तर काय होणार, त्याचं कंडेन्सेशन होणार. अशी ज्यावेळेस कंडिशन येईल त्या कंडिशन मध्ये प्रत्येक गॅस त्याचं टेम्परेचर जे असेल, सॉरी प्रेशर जे असेल, इंडिव्हिज्युअल प्रेशर, सो दॅट प्रेशर विल बी वेपर प्रेशर. आणि वेपर प्रेशर व्हॅल्यूज आर स्टँडर्ड व्हॅल्यूज, जसं की एअरचं किंवा वॉटरचं 1 बार प्रेशरला, 2 बार प्रेशरला किंवा 0.5 बार प्रेशरला ठराविक वेपर प्रेशर ठरलेला आहे. सो वेपर प्रेशर व्हॅल्यूज आर स्टँडर्ड व्हॅल्यूज. And depending on the difference between vapor pressure and partial pressure, various phenomena we observe. We observe boiling, we observe vapor pressure, we observe condensation. So that depends on the difference between vapor pressure and partial pressure. So we'll see that in next lecture when that psychrometry terms part will come. Okay. Okay. Up to now, this point we have seen the atmospheric air, which is a mixture of dry air, water vapor, and pollutants. Then we have seen moist air. Moist air is a mixture of dry air and water vapor. Then we have seen saturated air. Saturated air is a condition in which the dry air has hold maximum amount of moisture into it, and this vapor and liquid are in equilibrium. Then we have seen Dalton's law of partial pressure. Okay. Next thing in our this today's lecture and the last point here, it is temperatures. Okay. So up to this point in your career or in your engineering, when I say temperature, okay. So when I say temperature, we have studied only dry bulk temperature. Okay. So we have studied pressure, you have studied volume, you have studied temperature, you have studied entropy, then you have studied other properties of system. So temperature when we measure, and what your measure or you have studied up to this point in your career, that temperature has two different values. Okay. So in psychrometry, we don't consider only one value of temperature. There are two values of temperature. First is called as a dry bulk temperature. Second is wet bulk temperature. Now we'll see what is the difference here. So whatever temperature values we get from the measurement, जसं की आता HMT लॅब मध्ये तुम्ही एक्सपेरिमेंट, अच्छा सॉरी या असेंब्ली तुमच्याकडून एक्सपेरिमेंट झाला नाही, मे बी तुम्ही 80 डेज एक्सपेरिमेंट केले असतील. जर एखाद्या एक्सपेरिमेंट मध्ये मी टेम्परेचर मेजर केलं असेल एखाद्या सिस्टीमचं, किंवा मी बसले बसले माझ्या मोबाईल मध्ये मला ते टेम्परेचर दिसतं पंढरपूर सिटीचं, किंवा तुम्ही ज्या सिटीमध्ये असतात त्याचं तुम्हाला टेम्परेचर तुमच्या मोबाईलच्या स्क्रीनमध्ये दिसत असतं. सो दॅट टेम्परेचर व्हॉट यू गेट बाय युझिंग अ सिम्पल टेम्परेचर मीटर, सो दॅट टेम्परेचर इज नथिंग बट द ड्राय बल्ब टेम्परेचर. तुम्ही त्यात काय करताय तर ड्राय एअरचं टेम्परेचर मेजर करताय. बट इफ यू सी, इफ आय वेट माय स्किन, किंवा माझे जर कपडे ओले असतील त्या जर टेम्परेचर माझ्या बॉडीचं घेतलं तर ते कमी येतं. राईट. सो यू कन्सिडर टू सिच्युएशन्स. एक आपण नॉर्मली बसतोय रूम मध्ये, ठीक आहे, आपण आपलं बॉडीचं टेम्परेचर मेजर केलंय. तेच जर मी बाहेर जाऊन आलो, बाहेर पाऊस पडत होता, माझे कपडे ओले झालेत, मी घरात आलो आणि त्यावेळेस जर माझं मी टेम्परेचर मेजर केलं त्यावेळेस ऑब्व्हियसली ते कमी असणार आहे. प्रोव्हाइडेड, आता ह्यामध्ये कसं होतं की ऍटमॉस्फिअर तर सगळीकडे सेमच आहे, ऍटमॉस्फिअरचं टेम्परेचर देखील सेम आहे, बट बिकॉज ऑफ इव्हॅपोरेशन ऑफ वॉटर वेपर्स फ्रॉम माय बॉडी, okay, for that case my temperature is reducing because of evaporation of water. वॉटरचं इव्हॅपोरेशन होतं म्हणजे काय होत असतं तर त्यातून आपण लॅटेंट हीट ते ऍब्झॉर्ब करत असतं. जसं तुमच्या डेऱ्यातलं पाणी असतं, डेऱ्यातलं पाणी तुम्ही बघता की तुम्ही समर मध्ये ठेवलं तर थंड पडतं, त्यामध्ये काय होत असतं तर सरफेसला वॉटरचं इव्हॅपोरेशन होत असतं. वॉटरचं ज्यावेळेस इव्हॅपोरेशन होतं त्यावेळेस वॉटर काय करतात तर ते लॅटेंट हीट काढून घेत असतं. त्यामुळे तुम्हाला जाणवेल की तुमच्या डेऱ्यातल्या पाण्याचं बराचसा एनर्जी कंटेंट कमी होतो आणि त्यानंतर त्यामध्ये टेम्परेचर ड्रॉप व्हायला चालू होतं. Okay, so this is the process. So whatever temperature we measure with the help of temperature meter normal, that is a dry bulb temperature. If I weight that temperature meter, तर ते टेम्परेचर मीटरला जर मी समजा ओलं कापड लावलं तर त्या केसमध्ये काय होणार आहे, माझं टेम्परेचर ऑब्विसली कमी होणार आहे बिकॉज ऑफ इव्हॅपोरेशन ऑफ वॉटर वेपर फ्रॉम द क्लॉथ. ठीक आहे. So we'll see what are these temperatures here. So first one here, it is a dry bulb temperature. So dry bulb temperature, in short, we write it as the DBT. So DBT, the actual temperature of gas or mixture of gases indicated by an error-free temperature measuring device. So they have said error-free. So this is the duty of that engineer, that he should have calibrated all his devices. So हे तुम्ही तुमच्या sorry, not the meteorology. You studied this in your triple M. Like metrology and measurement, in that subject you might have studied the calibration of devices. एखादा डिव्हाइस मी ज्यावेळेस परचेस करतो, जसं की टेम्परेचर मीटर असेल, प्रेशर सेन्सर असेल, ते पहिल्यांदा कॅलिब्रेट केले पाहिजेत, कारण ते काही रिडिंग देऊ शकतं. सो दॅट इज शुड बी एरर फ्री. So dBT is the actual temperature of gas or mixture of gases indicated by error-free temperature measuring device. Second is wet bulb temperature. So wet bulb temperature, in short, we write it as a WBT. So WBT is the temperature obtained by an accurate thermometer having a weak moisture with a distilled water. Okay. So whatever that bottom portion, ज्यामध्ये मर्क्युरी असतो, त्या मर्क्युरीच्या बॉटम पोर्शनला मी काय करणार, ओला कपडा बांधला. ओला कपडा बांधल्यामुळे काय होणार, त्यातून वॉटरचं इव्हॅपोरेशन स्टार्ट होणार. वॉटरचं इव्हॅपोरेशन झाल्यामुळे काय होणार, त्यातलं आता टेम्परेचर ड्रॉप होणार. सो what is the difference between dry bulb and wet bulb? In dry bulb, we are considering only dry air. Wet bulb, in that we are considering the moist air. So obviously, because of water content, the temperature will be lower. Best way to explain this wet bulb temperature is your water cooler. ज्यावेळेस तुम्ही समर मध्ये वॉटर कूलर लावतो आपण, त्या कूलर मध्ये पाणी टाकतो, फॅन मधून मग आपल्याला ते थंड हवेचा झोका येतो असं वाटतं. बट दॅट एअर सिम्पली कंटेन्स द वॉटर पार्टिकल्स. ठीक आहे. म्हणजे मागे एक मेश असतं, मेश मधून पाणी पाझरत असतं, कुठं फॅन असतो, फॅन काय करतो, एअर फ्लो क्रिएट करतो. मग त्या मेश मधून जे पाणी पडत असतं, तर त्यातले पाण्यातले काय होतात, वॉटर पार्टिकल्स एअर फ्लो मध्ये मिक्स होतात. ते जे काही मॉइस्ट एअरचा फ्लो असतो तो आपल्या अंगावर येतो. त्यावेळेस काय होतं, ऍक्च्युअली बिकॉज ऑफ इंड्युस्ड वॉटर वेपर्स, द टेम्परेचर ऑफ द स्ट्रीम डिक्रीज येते. जी काही एअर स्ट्रीम आपल्या अंगावर येते, त्याचं टेम्परेचर ऑटोमॅटिकली डिक्रीज झालेलं असतंय, त्यात वॉटर कंटेंट असल्यामुळं. सो दॅट इज द कन्सेप्ट ऑफ वेट बल्ब टेम्परेचर. वेन एव्हर यू मिक्स air with water and there is evaporation of water, in that case temperature decreases. Okay. So I'll show you one diagram. It is there on the next slide. Then we'll see what is the dew point temperature. So the previously they were using this device which is called as sling psychrometer. Sling psychrometer, the name suggests. So there is one handle here and there is a joint here. So this joint will give the sling motion to the device. Now if you see the actual device here, there are two temperature scales. Okay, so this one scale, this is used for dry bulb thermometer. So it will give the temperature as a DBT, dry bulb temperature. If you see the second scale here, temperature scale, so this is a second temperature or thermometer here. So at the bottom of this thermometer, it is covered with a wet cloth. So there is a wet cloth which is surrounded here. Because of this, what will happen? There is a evaporation of water particles, and because of that, the temperature will be reduced. So another thermometer will give you wet bulb thermometer. First thermometer will give you dry bulb temperature. This will give you wet bulb temperature. Now the uses, how to use this. So you have to hold this handle here and you have to rotate it. Not the handle, this above section that you have to rotate. Because of this joint, it will rotate. Why we are rotating? Because we want faster evaporation of water. So the more the angular velocity will provide to this device, greater will be the evaporation of water. Greater will be the evaporation of water, temperature will be reduced. So this way we measure the dry bulb temperature and wet bulb temperature. So this is a conventional device. Then we have here digital psychrometers. So this is I have taken image from the Amazon. It is available on Amazon. So this is a digital psychrometer. It will give you all the values. All the values means it will give you value of dry bulb temperature. It will give you value of wet bulb temperature, as well as it will give you value of humidity. So if you see here, it is mentioned there humidity meter. So it will give you all the values dBT, WBT, and RH values. So that will be given on this digital screen. Okay. So in this, they use this humidity sensor and temperature sensor. From that data, they interpolate the data and they calculate the WBT and dBT and relative humidity. Right. So that is about the dry bulb temperature and well bulb temperature. So difference here it is. This is about the dry air. This is about the moist air. Third, here we have a dew point temperature. So dew point temperature, it is a temperature at which the liquid droplets just appear when the moist air is cooled continuously. So I have told you about the condition of saturated air. Saturated air म्हणजे काय असतं? Dry air has maximum, it has reached to its maximum capacity of holding water particles. If I cool, after that, what will happen? The water particles will condense. So it is a temperature, dew point temperature is the temperature at which the liquid droplets just appear. Just appear means it will start to condensate when the moist air is cooled continuously. The equipment used for measuring the dry bulb temperature and wet bulb temperature simultaneously is known as a psychrometer. So this device, what you have seen here, this digital one, that will give you the value of dew point temperature also. ओके. सो ड्यू पॉइंट टेम्परेचर म्हणजे काय होतं की ड्यू पॉइंट टेम्परेचरच्या खाली जर तुम्ही टेम्परेचर रिड्यूस केलं तर त्यामध्ये काय होतं वॉटर टेम्परेचर वॉटर पार्टिकल्स विल स्टार्ट टू कंडेन्सेट. त्यामुळे मी तुम्हाला एक्झाम्पल दिलं की पेप्सीची बॉटल किंवा एखादा कोकचा कॅन असतो त्यावेळेस तुम्ही फ्रीज मधून बाहेर काढता त्यावेळेस त्यावर तुम्हाला दिसतं की लिक्विड पार्टिकल्स किंवा वॉटर पार्टिकल्स किंवा ड्रॉपलेट त्याच्यावर फॉर्मेशन होतात. का होतात तर त्या कॅनचं किंवा त्या बॉटलचं टेम्परेचर हे ड्यू पॉइंट टेम्परेचरच्या खाली असते. आता नॉर्मली या कंडिशन मध्ये फॉर वॉटर इट इज 7 डिग्री सेल्सिअस. जर तुमचं त्या कोकचं किंवा कॅनचं टेम्परेचर 7 डिग्रीच्या खाली असेल त्या केसमध्ये काय होणार आहे? ऑटोमॅटिकली बिकॉज ऑफ द ड्यू पॉइंट टेम्परेचर, बिकॉज द टेम्परेचर इज लोअर दॅन द ड्यू पॉइंट टेम्परेचर, water particles will start to condensate on the surface of Coke or the Pepsi bottle. Okay, so that is the concept of dew point temperature. Right? So these are the figure already I explained to you. This is a conventional psychrometer. This is a digital psychrometer. Okay, so if you have any doubts, you can ask. Because this is the end of this lecture. This is just an introduction to the chapter. Next lecture, I will thoroughly explain you what is the significance of vapor pressure, because that significance only will explain you what various activities which happen in the nature, like condensation, evaporation. His activity ahead. These two activities depends on only the difference between partial pressure and vapor pressure. Okay, one question I have here from Rohit, how to measure dew point temperature? See, dew point temperature is different for different pressure. Okay, so in next lecture, maybe I will show you that psychrometric chart. So in that psychrometric chart, that this point dew point temperature is calculated. So it is like experimentally calculated. जसं की आता 1 bar pressure असेल, तर 1 bar pressure ला आणि ह्युमिडिटी बाहेर किती आहे, समजा बाहेर 50% ह्युमिडिटी असेल, त्या केसमध्ये ड्यू पॉइंट वेगळा असणार आहे. 7%ला ड्यू पॉइंट वेगळा असणार आहे. So it is like experimentally calculated on the, and all these experimental values, these are plotted on one chart. That chart we are calling it as a psychrometric chart. Okay, so if I if you give me some 2 minutes, I will show you. I'll check if I have that psychrometric chart. Uh, Okay, so what you see on the screen, it is actually is a psychrometric chart. Anyway, we are going to see we are going to construct this in upcoming lectures. But still, I will show you. So this is a chart will give you all the values, all the information related to the atmospheric air. So this x-axis here, it stands for the dry bulb temperature, and then y-axis it stands for specific humidity. So what you see here, this line here, so this is a 100% saturation or 100% relative humidity line. 100% relative humidity means that air is being now saturated. आता ह्याच्या पुढे काय होणार आहे, डायरेक्ट कंडेन्सेशन स्टार्ट होणार आहे. So what you see here, the values like 5, 10, 15. So these are experimentally calculated values. So these are the dew point temperatures. Okay. So we'll see this in upcoming lectures, how to construct the psychrometric chart, what are the processes on the chart, right? So for today only, I'll just recap again whatever today we have seen. So today we have started our chapter with the atmospheric air. Then we have seen the moist air. Then we have seen the saturated air. Then the very important Dalton's law of partial pressure. Then the temperatures. Last point was the dry bulb temperature, wet bulb temperature, and dew point temperature. Okay. So quickly I will take the attendance and then we can stop. So very important chapter is now going on. Inform your classmates, your friends to attend this, because this concept only will help them when they will study the air conditioning system. You cannot study the complex subject without the understanding of basic subject, right? Okay, so I have taken your attendance. Thank you for attending. See you in next lecture. Thank you.